కనెక్షన్స్ ఇచ్చినప్పుడు ఒకదానికొకటి మనం పేర్ చేస్తూ ఉంటాం, పెట్టుకొని ఉంటాయి వైర్స్, 2 వైర్స్ చూసారా?
Yes, ma'am.
Yes, ma'am.
That means 2 wires twisted with each other. సో మనకేంటి ఇక్కడ 2 lines parallel గా ఉంటుంది, రైట్? In the parallel transmission line, so both lines having separated with each other with some insulation gap, right? So because of this insulation gap, losses occurs highly. Then the second one is the twisted cable, so twisting with each other like that. So positive and negative, 2 wires twisted with each other to avoid the insulation losses. Okay, so but these are also used in short distances because of having some losses, right? Okay, so not used for high frequency, only used in low frequency. Okay, and third one is the coaxial cable. So coaxial cable means మనం టీవీలో యూజ్ చేస్తాం కదా కేబుల్, డిష్ కనెక్షన్స్ లో. ఓకే, that means more advantages these two. Okay, so first parallel, second twisted, then third one is a coaxial, means when compared to these two, this one is better, right? So coaxial cable ఎలా ఉంటుంది మన స్ట్రక్చర్ లైక్ దిస్. So 4 layers, first, second, third, fourth. So 4 layers ఉంటుంది. Because these two having only single layers, right? Directly wire, మనకి వైర్ అనేది కనబడుతుంది. But in these 4 layers are there, the last layer the signal will be passing. So this is a conductor, right? So through this only the signal will be passing. So to protect this signal layer, we are using the dielectric material, and to protect these two, again it will be covered with plastic shield. Then finally we are coated with jacket. That means, so మనకి సిగ్నల్ పాస్ అవుతున్న కండక్టర్ కి ఎన్ని లేయర్స్ ఉన్నాయి? ఎక్స్ట్రా 3 layers. So to avoid the losses మనకి. Okay, that's why we said here, when compared to these two, this one is better. Okay, this is a coaxial cable, third type of transmission line. Okay, so మనకి landline connections ఉన్నాయి. In that also we can use the coaxial cables and dish connections. Okay, etc. We are using the coaxial cables. Okay, and what is the fourth one?
Waveguide.
Waveguide. So what is waveguide? I already told you.
It is used to transmit microwave frequencies.
Shiva Krishna. Used for transmitting the microwave signal. That is a waveguide. Okay, that means microwave frequency means very high frequency. Okay, so here according to the application we can use the type of waveguides. So the H is electric. Waveguide. It is in the circular mode. Circular waveguide. Or it is a rectangular phase. Then rectangular phase. So the types of waveguide. So according to the application we can use. Okay, and these are waveguides are better than first 3. Okay, when compared to these 3, these having low losses and can be transmitted for long distances. And using very high frequency signal, right? clear? Fourth one. And what is the fifth one?
Optical fiber.
Optical fiber.
Fiber. So optical fiber means which is used to transmit the light signal. Light signal. So before four transmission lines will be used to transmit the electrical signal, right? So parallel, twisted, coaxial cable and waveguides. So for these four will be used for transmit the electrical signal. That means the electrical signal may be with low frequency or high frequency, right?
It's good.
So in the last one is the optical fiber. So this transmission line will be used for light signals. That means so these will transmit only the light signal. Still very fastest communication. This one is the.
మ్యామ్ ఆప్టికల్ ఫైబర్ అప్లికేషన్ అంటే ఎక్కడ యూజ్ చేస్తారు మ్యామ్?
సో సేమ్ ల్యాండ్ లైన్ ఫోన్ లో యూజ్ చేయవచ్చు మనం. కేబుల్స్ ఉన్నాయి కదా డాటా కనెక్షన్. సో వైఫై యూజ్ చేస్తున్నారు మీరు.
అవును మేడం.
వైఫై యూజ్ చేసినప్పుడు కేబుల్స్ యూజ్ చేస్తున్నారా? సమ్ టైమ్ ఇఫ్ యూ నీడ్ more and more data, then we can use the optical fibers. సో డాటా ట్రాన్స్మిషన్ నాకు హై ఉండాలి అండ్ లాంగ్ డిస్టెన్స్ ఉన్నప్పుడు దెన్ we can use the optical fibers.
ఓకే మేడం.
Okay? So these
Okay,
are the
ma'am.
types of transmission line. So this one clear?
ఎస్ మ్యామ్.
So what is transmission line, what is waveguide and types of transmission lines. Okay? And next, equivalent circuit of transmission line. Okay? So it is the most and most important topic, equivalent circuit of transmission line. So compulsory question mark. Okay, so in this we are using the L, R, C, G component. So what is L?
Inductor.
ఇండక్టర్,
R,
రెసిస్టర్,
C,
Capacitor.
G,
Ground. Galvanic.
huh? Ground. Ground, huh? What I written here?
కండక్టెన్స్,
Conductance. Okay. So using these four components, we can draw the equivalent circuit of transmission line. So first one is the inductance, then resistance. So here we can take, so these two are will be designed in series connection, and parallelly we can take the, this is a C, this is a G. Okay, so it is a one unit. L, R, C, G. So L and R will be placed in series and C and G. That means okay, capacitance and conductance will be placed in parallelly. Okay, so this is the one unit, and same circuit will be repeated for another also. L, R and C, G. Okay, then say this is the one unit, and this is another unit. And again we can take L, R, here C and G. This is another unit.
మేడం జీ సింబల్ ఎట్లా మేడం?
Same like resistance.
మ్యామ్ మనం ఎన్ని యూనిట్స్ ఫామ్ చేసుకోవాలి మేడం?
ఎలా అయినా చేసుకోవచ్చు, ఎన్నైనా చేసుకోవచ్చు. This is a transmission line. So here source and here is the destination, right? Okay. This is the equivalent circuit of transmission line. Okay, na? So this is a 1 unit. LRCG. This is a 1 unit, second unit, third unit, fourth unit. Allah. Okay, na?
ఓకే మేడం.
So it is an equivalent circuit, right? And what is lossless transmission line? So what is lossless transmission line? So lossless transmission means there must be no losses, right? So it can be taken in high frequencies. At high frequencies. Okay? So at high frequencies what happens? L and R is there, right? Okay, na? So when compared to this one, the reactance of L is more greater. That means XL is very very high than R. Reactance of inductance is more greater than R. This is the first condition. What is the second condition? Reactance of capacitance is more greater than G. Conductance. Okay? Because these two are storage elements, right? Yes or no?
ఎస్ మేడం.
మేడం
That's right. At very high frequencies, what happens? Reactance of inductance is more greater than resistance because these two are in series, right? And here what happens? Capacitance reactance is more greater than conductance. Okay, so more greater than means these two will be neglected, right? Yes or no?
ఎస్ మేడం.
So then what happens? In the transmission lines we have only L and L and C. So this circuit can be called as lossless transmission line. Okay? So clear? Lossless transmission line using L and C only. Draw the lossless transmission line అని అడగొచ్చు, లేదంటే draw the equivalent circuit of transmission line. ఈ రెండిట్లలో ఏదన్నా ఒకటి Okay, Amma. At very high frequencies, that means at radio frequencies, the reactance of inductance more greater than resistance, and reactance of capacitance is more greater than conductance. That's why R and G will be neglected in the transmission, lossless transmission line with L and C. That means series inductance, shunt capacitance. Okay? So this one clear?
Yes, ma'am.
Equivalent circuit of transmission line and lossless transmission line.
Yes, clear.
So next one is the primary and secondary constant. Primary and secondary constants which will be used in okay. So what are the primary constant? L, R, C, G. Okay? L, R, C, G. So these are the primary constants. Okay? And while coming to secondary constants, characteristic impedance Z0. Characteristic impedance is the first one, and second one is the propagation constant. నేను మళ్ళీ రేపు అడుగుతానమ్మా క్వశ్చన్స్. Okay? What is the third one? Attenuation and phase constant. And fourth one is the wavelength. Okay? So primary constants means L, R, C, G. And secondary constant, what is the first one?
Z0.
Characteristic.
Characteristic impedance is Z0. Second one is the propagation constant. And third one is the attenuation and phase constant. Fourth one is the wavelength. Okay. So about all 8, tomorrow I will explain.